Good morning. So last class, what we have seen over on it, Arena, we have seen about an inclinometer. So inclinometer, which is designed to measure the angle of an object with respect to the force or gravity. Okay. So today our last topic is about around an gyroscope. Okay. So before going into an gyroscope, so let me study about an what is the meaning of an compass actually. So we know that we already used the compass, right? Actually, the compass is an instrument which is used for navigation and orientation, which shows direction that relative to the geographic coordinate directions, or usually a diagram which is called a compass rose, which shows the directions north, south, east, and west, and the compass face as approved initials. Okay. And when you are saying about an this compass, we'll have about an magnetic compass and non-magnetic compass. So in non-magnetic compass, actually, we'll have two other ways in order to find not than use the of magnetism. And from a navigation point of view, a total 7 possible ways which exist. Okay. And obviously, we'll be using two sensors that utilize two of the remaining six principles, which is often also called as compass. That is, we'll have a gyro compass and GPS compass. Okay. So the gyro compass, when you are saying about an, actually it is similar to a gyroscope. It is a non-magnetic compass which finds the true north by using a fast spinning wheel and the friction forces in order to exploit the rotation of the earth. So gyro compasses, which are widely used on ships, so they have two main advantages. One to be that they'll find true north and they are not affected by the ferromagnetic metals. So what are all the ferromagnetic metals? So which includes iron, steel, cobalt, and nickel. Okay. And when we are saying about an lost ships, which rely on a gyro compass, so it will be only serves as an backup. So apart from that, we'll have a so this compasses which are still widely used, they can be small because they'll be using simple reliable technology, and it will be comparatively cheap when you're comparing with the GPS compass, and similarly it requires no energy supply, and like GPS they will not be affected by any objects. Okay, so this is about an introduction about an gyro compass. Now let me come back to the gyroscope. So actually the gyroscope is basically a device that takes the help of the Earth's gravity in determining the orientation. Actually, it is a type of sensor which we find IMU, it is the internal measurement unit, a gyroscope which can be used to measure the rotation on a particular axis. The device which consists of a rotor, which is nothing but a freely rotating disc. Okay, the rotor is mounted on a spinning axis which is present in the center of the under large wheel. Actually, a gyroscope is probably the most common navigation sensor. Okay, so in many cases, a geomagnetic field is either absent or it is altered by the presence of some disturbances. So gyroscope, which is an indispensable sensor, which is defining for the position of a vehicle. Okay, so a gyroscope or a gyro for a short, which is meaning that keeper of direction, which is like a pendulum in a clock is a keeper of time. So a gyro operation is based on the fundamental principle of the conservation of angular momentum. In any system of principles, the total angular momentum of the system relative to any point fixed in space which remains constant provided no external forces act on the system. Okay, and when you are saying about an working principle, so before that, let me see about an design of gyroscope. Okay, so that a gyroscope, which is to be a massive rotor, which is fixed in light supporting rings, which is called the gimbals. Okay, and apart from that, the gimbals, which is consist of frictionless bearing that isolate the central rotor from outside torques, the axle of the spinning wheel, which defines the spin axis. Okay, and the rotor possesses 3 degrees of rotational freedom and spins about an axis. It occurs extraordinary stability of balance at high speeds as it maintains the high speed rotation axis of an central rotor. Okay. And when you are saying about an working principle, the Coriolis force or the Coriolis effect is used in the measurement of angular momentum. A gyroscope sensor works on the principle of conservation of angular momentum. It works by preserving the angular momentum. So in a gyroscope sensor, a rotor or spinning wheel is mounted on a pivot. So this pivot allows the rotation of the rotor on a particular axis, which is called a gimbal.